Fast Start 2014, question 16. Let's go to a calculator page. Let's also make sure that we're in radian mode. Let's go to document settings, and yes, we can see we're in radian mode. We're going to go for real or complex. We're going to go for rectangular, just in case we get some complex numbers out, and we'll make that the default. Now we're being asked what the polar coordinate form for a complex number is. Now what we can do, just to help ourselves with this, I can define a function. I'm going to call it z, that uses two arguments, r and theta, and that's normally going to be defined as r multiplied by cos theta. So press trig twice and move outside the bracket, plus I, so we press the pi button, move across to I, multiplied by r multiplied by sine, so we press trig sine of theta. Whoops. And so if I wanted to have a guess as to what the polar form of the number -1 is, I can just press the var key to pull up this function. I think its radius is 1, and I think its argument is pi, so I'll just type in pi, and this does return -1. So in polar form, it would be 1 lot of e to the I pi, or 1 lot of cis pi. Now it's wanting us to write down the solutions to the equation z to the power 4 plus 1. We can use a built-in template for that. I can go to algebra, polynomial tools, and find the roots of a polynomial. Now z to the power 4 will be a polynomial of degree 4, and we're interested in complex roots. So we'll click OK, and that's looking for the coefficient of the power 4 term, which here is 1, and then the coefficients of all the other terms are 0, except for the constant on the end, which is a +1. And we put, it just designs the command there, c polyroots, and we get all the values coming out. So lots of 1/√2's there, if we wanted to write it in rectangular form, and we're going to leave it in that form for a minute. Now we're going to write down the 4 solutions of the equation z to the power 4 minus 1, so I can just re-execute this command here, and to the -1, and we get those solutions there. And we've got to plot all of these on an Argand diagram. So the way I've set it up will allow us to very quickly go to creating a new page. So Control Doc, we'll go to a list and spreadsheet, and what we're going to plot at the real numbers. So I'm going to call them RE for the real numbers, real components, and IM for the imaginary components. And I'm going to populate these lists with the real and imaginary components of these answers. So the command we're going to go for is RE. We're going to define to be the real values of the answer to that previous statement, and we'll call the IMs, that list of numbers control template, to be the imaginary values of that previous answer, like so. And if I go back to the list and spreadsheet, you'll see that everything has now been populated in according to those. Now if I now stick on the end these values, it's going to overwrite. If I were to do the same sort of thing, it would overwrite those previous values. So I can probably do these manually. The number -1 is -1 real parts and 0 imaginary parts. The number I is no real parts and 1 imaginary part. The number -I is no real parts and -1 imaginary part. And finally, the number 1 is 1 real part and 0 imaginary parts. So let's just plot these on a diagram. What I could do is I could press Control Doc to insert a new page. I'll go to Data and Statistics. I want to plot my real numbers along the x-axis and my imaginary numbers on the y-axis. And you can see it's not quite a circle here because of the distortion, but we're sort of expecting it to be a circle. Maybe the best place to do it is not in this Data and Statistics page. Let's now insert a graph page. So Control Doc, go to a graphs page, and this time I'm going to menu, graph entry, edit, and I want to go to a scatter plot. So my scatter plot is going to be my real numbers for my x values and my imaginary numbers for the y values. When I press enter, I get a lovely circle. I can just scroll, grab the axes, stretch it out, and you can see that I've got all the points there. To prove that this really is a circle, I could do menu, geometry, shape, and go for a circle that way, and basically plot a circle through them. Alternatively, I could go to graph entry, edit, type in the equation of a circle, and the circle in this particular case is going to be centered on 0 with radius 1, and lo and behold, the unit circle and the Argand plane. Now, being asked to show that solutions of z to the power 4 and solutions are also the solutions of z to the power 8, well, that's simply a case of going back to our calculator page and do my C polyroots command. I could be using z's here. Let's just do that for the sake of completeness. It's gone bold because we've got a function z, so I've just changed my mind there. We'll leave it as x's. And we'll do z to the power of 8, and we get those values there. Very similar, and I could go through the same process of defining the real values to be the real components of that list, and I can do the same thing for the imaginary components of that original list. And if we go back to our scatter plot, we should find that nothing has changed, even though we overwrote the old data with the new data. And for part E, we're being asked to identify all the solutions to that particular equation. However you go about doing it, we can use a C polyroots command here again. We could just replace x to the power of 8 minus 1 with instead x to the power 6 plus x to the power 4. Oops, we need to remember to move outside of the bracket. Sorry, outside of the power. X to the power 4, move outside, plus x to the power 2 plus 1. And we get a bunch of numbers which are looking awfully familiar. I could plot those on the diagram as well. So it'll be the real part, of all those numbers, and the imaginary will be the imaginary part of all those numbers. Now if I go back to the diagram, we'll see if there's, we're missing a couple. We're missing the ones that are actually on the x-axis. So it would appear to suggest that that polynomial given in part E, that z to the power 6, if I multiplied it by z minus 1 and z plus 1, it would give us z to the power of 8. So the diagram there and the missing roots gives you some indication of how this question all connects together. We're done.